Constructing a UART transmitter is extremely similar to constructing a UART receiver. It's just everything is in the opposite. So instead of doing oversampling, it's actually putting that 1 or keeping that 1 or zeros, whatever you want to put on the TX for 16 ticks, or if it's a stop bit, it's probably more. So what it actually does is the following. It actually takes ticks from the baud rate generator in here, and it takes a data in here, and whenever you issue a start, that means you're not idle anymore and you want to start transmitting. So you're going to move from the idle state, for example, and just drive this particular signal to 0 for a very specific period of time, and that's usually 16 ticks of the baud rate. So you're going to wait for 16 of these, and then you start sending the data. So its construction is extremely similar to the receiver, and you can see it here also from the code. So in the code, you will see that this is actually just a finite state machine, and that particular finite state machine has idle state, it has a start state, it has a data state in here, and it has a stop state in here. Okay, so let's take a look at the idle. So in the idle, you'll see the TX, which actually is the register that stores whatever the value of TX in here. Just generally speaking is left at 1 because we know at idle it's actually 1. Whenever you actually issue a start, that means you want to start. So it just tells you, okay, move to the start state. Okay, and it just basically moves the S next, which is actually, this is when the counter, because I'm utilizing some sort of a counter to see how many ticks happens. Well, I'm gonna start from now. I'm gonna basically count for like 7, 16, whatever it is that you want. Okay, it's generally 16 here because we're not oversampling. We don't care about the middle point in here because we're not sampling it, we're generating it. Okay, the same goes with the B next. Okay, what's the B next? Well, it's actually just an internal register that tells me what's here. I'll just basically store it at that point. Whatever is on this value, I'm just going to store it with whatever internal register I have. And you can see what B next is in here. It's actually just one of the registers that stores that value in here. Okay, so then what we have in here is in the beginning, you can see the start. It drives the TX here for 0, and you can see it actually does it exactly for about 15 of these ticks. So as long as it's not taking, it's actually following just an ASM chart basically. And once it's 15, I know that I'm done with it. I'm actually going to reset that counter one more time. I'm going to see how many data bits I have. I have 0 at this point, and now my next state is data, and then I move here to the data. So in the data, we'll see it's exactly the same as long as the T next basically will have whatever I have in the B register, which stored whatever was in the DN. Okay, I'll keep it at that particular value. Basically, keep the X at that particular value for exactly 15 times. Once it's done with the 15 times, you repeat, you keep repeating, you keep repeating, you keep repeating, and of course, you're changing the end state at that point, okay? You're following an ASM chart, a very simple ASM chart, and it just implements it as the receiver part.